In this video, we're going to continue talking about different types of reactions that you'll see in chemistry, and we're going to focus on acid-base reactions. Now, an acid-base reaction can also be called a neutralization reaction. And this is another topic that we'll go into great detail on, but it's important to know kind of the basics of it before we continue on in our chemistry quarter. In a neutralization reactions, an acid reacts with a base and the two neutralize each other, and they always produce water in this sense, and sometimes a weak electrolyte. And so this is kind of our simple version of acid-base chemistry, and we'll look into kind of exceptions to these kind of foundational rules that we set forth. So let's define what these things are. Now, an acid is always going to be a substance that can produce a proton or an H plus ion in water or in general. And so an example of this is hydrochloric acid. And what happens is that that bond between the hydrogen and the chlorine will actually dissociate. It'll break, and both of the electrons that make up that bond will stay with the chlorine, and our hydrogen will be left alone as as a cation, and our chlorine is now an anion. Now, hydrochloric acid is an example of a really strong acid, and so hydrochloric acid is most often separated into these two ions, actually. And the key part of this is that one of the things it separates into is this H plus ion right here. Now, a base is going to be anything that produces a hydroxide ion in an aqueous solution. And so something like sodium hydroxide, an ionic compound that dissolves in water, will separate and have a hydroxide ion that's dissolved in water. And now this is this is one of several definitions of what an acid is. We won't get into further definitions of what an acid is. But this is what we think of as the Arrhenius definition. And now we're going to test my ability to spell this on the notes. Forgive me if I messed it up a little bit. But this is our Arrhenius definition of an acid and a base that focuses on this production of either a proton or a hydroxide ion. So what happens in these neutralization reactions? Well, when we have an acid and a base together, they are going to neutralize the acidic and basic properties that these have. And the acidic property is the ability to produce these cation protons, these H plus ions. And the base's properties is able to accept those protons and form water with it if it's hydroxide that's accepting it. And so in a sense, what we're going to see in this reaction is that if we had nitric acid, which is another strong acid, react with calcium hydroxide, which is not super soluble, but if we get a little bit of it dissolved, then we're going to end up with something where our calcium and our nitrate ions are going to pair up to form an ionic compound, a salt in water. And the hydrogen from our acid and the hydroxide from our base are going to form a water molecule as a product. So the net ionic reaction that's really occurring here in this reaction is H plus OH minus forms water. And that's kind of our foundation for basic neutralization reactions. And we'll see water in a salt form typically. And so here's another example below of hydrochloric acid and sodium hydroxide, which we were talking about earlier. Again, we're going to take the hydrogen from our acid, and we're going to take the hydroxide from our base, and they're going to combine to form water. And that's going to leave behind a chloride anion and a sodium cation that will combine to form a salt that dissolves in water that's aqueous. So here's just some examples of acids and bases that are common. And we're really looking at, in black, the strong acids and strong bases, and weak acids and weak bases in pink. And we'll talk a lot more about what a weak acid and a weak base is compared to a strong acid and a strong base later on in this course. But these are useful to be familiar with. If you spill acid on yourself, it will burn your skin and do damage to your body. And if you spill a base on your skin, it will still do damage. It'll be more like it kind of almost feels, it looks like it's dissolving the skin instead. And so think of Fight Club, if you've ever seen that movie, the scene where they pour lye, which is a strong base, on someone's skin that's wet. and the fun kind of bubbling action that happens. Ugh. Anyway, so it's useful to know what a strong acid and strong base is. You can recognize it if you're confronted with it. And I don't expect you to memorize these, and we'll talk about these quite a greater extent later. I would like you to start recognizing that acids are always going to produce this hydrogen and lose it, and that bases will always have this hydroxide ion in this kind of limited view of bases that we're talking about, and be able to predict the products. And I think that's a really good foundation to start with. And then we'll get into a lot more detail later, which I think I've said like 5 times in this lecture. So I'm going to do a couple examples, and then there'll be another video with a practice problem you can try first. So what we want to do for these types of reactions is identify them as acid-base reactions, and then if we know the full chemical reaction, and then also we want to be able to predict the products. So looking at our first one, we have hydrochloric acid and barium hydroxide. So I'm seeing this hydroxide right here, and then this H on my acid that can combine and form water. And so it's just going to produce water, the phase of which is liquid because it's water dissolved in water, which is just water. And then the other piece here is this chlorine that's left over in barium. And so these are going to combine to form this salt that we can always look at our solubility table to decide if it's going to be soluble or not, but barium chloride. And in this case, we have a +2 charge on our barium. And I can tell because one, where it is in the periodic table, and two, I have 2 hydroxide ions, and they're each a -1 charge. So that means that barium needs to be +2. So I'll need 2 chlorine to balance the +2 charge of my barium. So I'll actually have 2 of these HCl, and that'll produce 2 water molecules in this reaction. And this will be either aqueous or solid, and we can check our solubility table for that. So looking at our table, we can find chlorine right here. And when we look at its exceptions, it's soluble in water. The only exceptions listed are silver, mercury, and lead. And so since we're combining this with barium, we can expect this barium chloride salt to be soluble in water. And then I have my prediction for my products. Now, if I was given just this reaction and asked what type is it, the thing that would be my big clue that this was an acid-base reaction is that I have something that has this hydroxide ion involved in my reactants, and that I'm producing water and a salt. And that's going to be my big tip-off that this is a neutralization reaction. All right, let's look at the next one. We have sulfuric acid and lithium hydroxide. So looking at my acid, I have this H here in front. That's going to be my acidic hydrogen. And my lithium hydroxide has this OH right here. Those are going to be my components for forming water. Now, in this case, the sulfuric acid has 2 acidic hydrogens that I can use. So that might form 2 products, or it might just form 1. I'll show you. So I'll say too that the acid is not always written first. I realize that in both these examples they are, but I will let you know in the problems which one is the acid, which one is the base if I'm expecting you to predict it, and it's not obvious. So what we then have left over will be the sulfates and the lithium. And so I think that in general, when we're looking at neutralization reactions, if we know we're working with strong acids and strong bases, we predict that we will use all acidic protons and the hydroxides if we have unlimited amounts. If we're working with at all a weak acid or a weak base as a component of this, then that changes. But so what I'll predict is that we'll form H2O, our water, and then we can form also lithium and sulfate. And when I'm predicting the compound that forms, that sulfate ion, if I get rid of both of those hydrogens, will produce a -2 charge. And my lithium, then I'll need 2 of these to counterbalance that -2 charge on the sulfate. That also means that I'm going to be using 2 equivalents of lithium hydroxide for every 1 equivalent of my sulfate. Or sorry, my sulfuric acid, and I'll have 2 equivalents of water that are produced. Now, I would also accept for an answer that we only produce 1 equivalent of water, and we form lithium hydrogen sulfate, like this.